Hello and welcome back to Enemy Assembly. I'm Seb, and this is the series where we take a dive into exploring the enemies from Dark Moon, the game that I am developing right now. In this episode, we're going to be looking at these little guys, the vampire enemies. Now, you might be thinking, vampire? Why did you call him a vampire? He's a bat. Well, it's because this guy actually has two forms, and when I hit him, you'll see he transforms into a vampire, and after a few seconds, he will turn back into a bat and try to get to me. So I'm really happy with these guys, and obviously having the transforming mechanic means they're a little bit more complicated than some of the previous enemies we've looked at. But that's not the only thing that makes them complicated, because as you can see, especially if I go down here, the previous enemies would not be able to find their way towards me, but this guy, the vampire, when they're in their bat form, they are able to pathfind around obstacles, which makes them a lot more aggressive, not to mention the fact that they are faster than the previous enemies. So if you compare them to the Ibats, they're a lot more tricky. With the exception that once you hit them, their passive hitbox is disabled for the duration of their falling and transforming animation, which makes them a little bit easier to avoid. I think the most interesting thing, aside from their ability to transform, obviously, which I'm pretty happy with that animation, is their sword swing animation. Now that is actually something that I modeled off of Alucard's attack from Symphony of the Night, because he's also a vampire, and I just thought it would give that Castlevania vibe and might feel kind of subtly nostalgic to people, so I thought that was a cool idea. In terms of actual damage, these guys do the same amount of damage in their bat form as the Ibats do, because it's the same sort of principle, so if you want to hear more about that, you can watch the Ibat video. And when they are in their vampire form, walking into them does 2 damage, as most enemies, and their sword does 8 damage, so they are pretty deadly. These guys are definitely a lot more complicated and dangerous than most of the enemies in the first area of the game. Now, one of the things that makes them more dangerous, of course, is their pathfinding, as I said earlier, and I want to talk a little bit about that. And part of the reason why I started with these guys, and when I was thinking of which episode should I make about which enemy from the second area of the game, I decided to go with the vampires first, because in their flying form, they use a type of pathfinding that we'll come back to in later episodes as well. And I can actually turn on debug mode to show you what's going on. So ignore the normal bat text. That was a debug feature that I implemented to check what state they were in. But yeah, as you can see, there's this sort of grid across the screen, and some of the tiles on the grid are green, and some of them are red. Now, this grid essentially is a map that is populated with all of the collidable terrain on the map, not including the platforms, because enemies can technically pass through the platforms. So any spot that is free of any obstacles becomes green, and any spot that is not free, as you can see on these slopes, that includes even if the tile is only slightly filling the grid space, it will be considered completely closed off and empty, and full, I mean. So by using this and a version of the A-star algorithm, which I didn't program myself, I'm using a pre-made game maker tool called the motion planning functions, we're able to generate a path that is the shortest distance, or the shortest path from one point to another. So every couple of frames, the bats will check their position in relation to mine and generate a new path. Once they've done this, they basically just take the point from the angle from the point that they are starting at to the next point on the path, and they try to aim in that direction. Now, if they keep doing that, eventually they will find their way to me. So it's basically, it's a little bit complicated, but it's kind of more complicated to explain, I find, than it is to actually see how it's working. They're basically just constantly updating their paths to get to me. Now, you might be wondering, why don't I update this path every frame? Why is it happening on a sort of rhythmic, choppy tempo? And that is just because using stuff like paths and the motion planning grid, running the A-star algorithm can become taxing if you are doing it a lot. And I wasn't running into any performance issues, but I figured, just to be safe, in cases where it doesn't need to be a higher refresh rate on the path, I would make it lower so that it's not taxing the computer as much. And it's the kind of thing that could be tweaked in the future if I did start to run into any sort of performance issues. So the pathfinding that these bats use is the same type of pathfinding that several enemies will use later on in the game, but it does have some limitations. You might be wondering, if I could program these guys to move like this, then why don't I make everyone move like this? Well, there are two reasons. One, some of the enemies I think work better if they're actually less intelligent and less of a challenge. So if they can't find their way to you as effectively, that actually makes them a little bit easier, and sometimes that's what you want. But the other reason, which is quite an important reason, is this system is not perfect. It has limitations, and there are situations where it will not work as you expect, and in those situations, it seems pretty janky and weird. So the main limitation is that in order for it to work, you really need to fine-tune the pathfinding or the movement of the enemies in relation to the path, as well as needing the actual environment to map really nicely to the grid that you have created. Because, as I said earlier, if you have just one pixel of solid block intersecting with one of the grid spaces, that whole grid space will be considered blocked. Now, why is that an issue? Well, the first issue is that if you want the enemy to be able to move around through this environment, and you have a bunch of spaces that really seem like they should be free from the player's perspective, but because of the way the grid system works, are considered filled up by the AI, then the AI will take weird paths that seem kind of irrational and don't really look natural. That's one issue. That issue is annoying, but it's not the main issue. The main issue that I've run into is that if these enemies ever somehow end up so that the point at which they are measuring the path start or the path end is considered to be inside of a filled up grid space, like a closed grid space, one of the red ones, then it simply fails to create a path, because it is impossible, according to the algorithm, to make a path through free spaces if it starts or ends on a filled space. I'm going to give a quick example. If I wall jump outside of the range of the map where the grids are created, so as you can see there's that section of green, the bats go into a fail-safe state that I programmed where they will rapidly move random directions. Now the idea is that in a normal area, they might clip into the red spot on a slope for a second, and by moving in a random direction, they'll quickly get back into the green spots and be able to pathfind again. Now, if there were enough red spots, or in the case where they are completely off the grid, like they are now, they have just completely lost control of what they're doing. Now, theoretically, you could also program another failsafe, like, in that case, make them just point straight at the player and move towards them. That could work, but it really depends on the level design. So I guess that's the main thing I'm trying to highlight, is that this pathfinding system, while very cool, pretty much only works if you design the levels specifically to work with it. In contrast to the way all of the enemies in the first area work, which is really, you could put those enemies in any environment and they would still work as you expect. Now, when these guys are in their vampire form, I don't really have much to say about their pathfinding because it's basically just a reworked version of the zombie werewolves. They will just move towards you. They have a bit of that horde mechanic where if they're next to each other, they will sometimes pause to allow for them to space themselves out. And when they're close enough to you, they'll do their sword swipe. So, yeah, that's basically all that I have to say about the vampire enemies for now, I think. They have more health and are generally more challenging than enemies in the first area. And they have 2 forms, and they have this pathfinding system, which we will be coming back to for later enemies. Thank you for watching. I hope you enjoyed the video, and of course, if you did, I would really appreciate it if you subscribed, commented, etc. And plus, if you subscribe, then you'll get to see more episodes of Enemy Assembly and more Dark Moon devlogs. In the next episode, we are going to be looking at the foxling enemies. Little knife-wielding fox people, assassin guys, and I'm really happy with how they turned out. I have a few interesting things to say about them and their pathfinding as well. It uses a similar system to these bats, except they are not flying enemies, which means there are some more challenges to overcome because they are ground-based enemies and have to contend with gravity. Anyway, for more about that, tune in to the next episode. Once again, thanks for watching. I'll see you in the next video. And as always, have a great day.